Hi guys, so today I'm going to start a new series on PyTorch fundamentals and coding part. So I'm going to start with lesson 1, which is foundation for deep learning and PyTorch. So first of all, we will know why foundation matters. So deep learning frameworks such as PyTorch abstract many low-level details. However, effective model design, debugging, and interview-level understanding requires clarity on the mathematical foundation that these frameworks automate. So this PyTorch is a framework of deep learning, which have already have some of the functions which abstract all the low-level details inside that functions. Like there is the dot backward function through which we you don't need to do that gradient thing, finding the partial derivatives of loss and this with respect to it. These things you don't have to do, like just when you write loss dot backward, it does automatically. So these low level details are abstracted inside that functions, and but to have a effective model design, debugging, and interview level understanding, we must know the fundamentals inside what is happening inside that abstract function. So training a neural network is fundamentally an optimization problems where parameters are iteratively updated to minimize the scalar objective functions. So training a neural network is optimization problem. It means that while training of at initialization, we initialize the weight with some random values, but to actually train a model, we need a particular weight through which we can predict the output. So to find that particular weight, we need to update it iteratively through some optimizations technique, which we will read further, like gradient descent and all. So we will read further in this course. And uh, so now we will know what is scalar, what is vector, matrix, and tensor. So what is scalar? Scalar is a single numerical value with magnitude only and no directions. Like example, you can have loss values. It is only just a numeric value. Temperature, learning rate. This parameter, this what we say, these units don't have any, like they don't have any numeric values. They don't have any directions. They are just a numerical value. In tensor terminology, a scalar is a zero dimensional tensor. So scalar is just a zero-dimensional tensor. If we take it in a, if we think scalar in a term of tensor, so it is just a zero-dimensional tensor. Now, what is vector? Vector is a ordered collection of number with magnitude and direction. So you know, you must have read this in your physics lectures. What is vector? Vector is just a vector is something which have magnitude as well as direction. So it is ordered collection of number with magnitude and direction, just like feature vector. We will read about it further. Velocity, like velocity have a magnitude as well as direction, like in which direction actually that velocity is. So it is a vector. And in tensor terminology, a vector is one dimensional tensor. So it is a one dimensional tensor. We like for vector we say it is a one dimensional tensor. Now what is matrix? A matrix is two-dimensional arrangements of number organized in row and columns. A matrix commonly represents linear transformations. Weight matrix is fully connected layer. Yeah. So what is matrix? You know, matrix is just like having m cross n rows and columns like a thing. So it is two-dimensional arrangement in x and in y. So it is a two-dimensional arrangement, and matrix is also known as two-dimensional tensor. Now. What is tensor? Tensor is a generalized multi-dimensional arrays like scalar, vector, and matrices are all special case of tensor. We just now we read this like zero-dimensional tensor. We call it that scalar. One-dimensional tensor we call it that vector. Two-dimensional tensor we call it as matrix. And if there is higher d-dimensional tensors like images, video, batch data. So tensor is just a generalized multi-dimensional arrays. You can have more than two, other three, four, five. Deep learning frameworks operate entirely on tensor on regardless of dimensionality. So yeah, deep learning frameworks actually they like they operate on any number of any d tensors. So it is tensor is just a generalized multidimensional array. Now, uh, yeah. Now we will read what is loss function. A loss function quantifies the error between the model prediction and ground truth value. So what is loss? So the difference between that actual correct value. Like for the take a case of house prediction. So actual house rent value and the value which you predicted, what is the difference between them? That is loss. That is actually the loss. A loss function, what is loss function? Loss function quantifies the error. That difference is error, and the loss function is used to quantify that error between model prediction and the ground truth value. So a loss must be a scalar tensor. Yeah, loss we have read here, like loss is a scalar. Loss value is a scalar. It need to be scalar tensor. We will read why it should be scalar tensor further in this course. And here, optimization algorithms require single numerical objective. Yeah, so this is only the reason. Why loss should be a scalar? So optimization algorithm which actually update the weights always want a single numerical objective. If it will be a vector, it means that it have a it is it have more than one values or more than one numerical objective, then optimization algorithm will confuse that in which direction it should follow. So there and how should it accumulate all the gradients and make a single gradient, so that it can use it as a single numerical objective, so it gets confused. That's why we should have loss is always a scalar tensor. uh, this is one important question actually, which comes in interview. Key insights like backpropagation is defined only for a scalar objective. Yeah, that's why a backpropagation is always defined on scalar objectives, because if it will be a vector, or if it will have a multiple numerical objectives, it will get confused that which one should it follow. That's why it is always a scalar. Derivatives and gradient, given like if given a function y equals to 3x square, the derivative with respect to x will be 6x. I will note it. In neural network, derivatives are used to compute gradients, which indicates how each parameter influence the loss. So yeah, so when we find the objective as a loss function, then we find its gradient with respect to weights which need to be updated. So that is known as gradient. Derivatives are used to compute gradients, and which indicates how parameter influence the loss. Why neural network require gradients? Training a neural network involves minimizing a loss function. Gradient provide direction per parameter update and magnitude of change required. So why we need a gradient? So while training a neural network, we start with a random weight, but we need to have a correct weight which minimize our loss. Like when we have a random weight through which we find our y and we try to find the loss. Now we our objective is to minimize the loss function. So to minimize the loss function, we need to update the weight and have a correct weight which minimize the loss function. So that's why gradient is used to provide the direction of parameter update. Direction of parameter update means like in which direction we need to update. We should move like in a contour plotting of that loss function, which direction we need to move, in right direction and left direction. Like right direction, left direction tells us that do we need to decrease the do we need to move in right direction get to reach minima, or do we need to move in left direction to reach minima? And it also tells us like how much magnitude of change is required to minimize the loss. So gradient guide optimization towards parameter values that reduce the loss. Yeah, gradient indicate the direction of steepest descent in the lost landscape. So gradient tells us what is the direction of steepest descent. Like which direction should we follow so that we can reach to the minima in minimum amount of time. Yeah. So what breaks without gradient? Without gradient computation, forward pass still executes, loss can be calculated, parameter cannot update it meaningfully. Because during forward pass, we don't need to know the gradients. So forward pass will execute, loss will be calculated, but while backward propagation, we need to have during backward propagation, parameters get updated meaningfully. But if we don't have a gradient, then how the parameters will get updated? So training collapse with random guessing or stagnations. Without grading, learning is impossible. Now training pipeline summary. So the neural network training process consists of three tightly coupled steps. So first, forward pass. Forward pass is just used to compute prediction and then loss. In backward pass, we compute gradient of loss with respect to parameters. Like parameter here is weight and bias. So we compute gradient of loss with respect to them. And in optimization step, we update the parameters with gradient. Like weight get updates like this, like w equals to w plus learning rate into derivative of loss with respect to particular parameter, its weight, then dl by dw, its bias, then dl by dv, in this way. So removing the backward pass breaks the entire training process. Now, key interview takeaways is loss is a scalar tensor, model weights are tensor, gradients are derivative of loss with respect to parameters, and deep learning training is an optimization problem. Yeah. Now, we will read PyTorch tensors and automatic differentiations. What is PyTorch tensor? A PyTorch tensor is a multi-dimensional numerical array with optional gradient tracking. Unlike NumPy arrays, PyTorch tensor can record operation to enable automatic differentiation. So a PyTorch is tensor is a multi-dimensional numerical array. Yeah, we know it like tensor is a multi-dimensional numerical array with optional gradient tracking. So what happened here? They track your computation through computational graph, and they automatically find the gradients. So they record the operation to enable automatic differentiation. This requires grade flag. When a tensor is created with requires grade equals to true, PyTorch tracks all operation involving that tensor and construct a computation graph. So we will see it with example how it happens. Now take a case of example x is equal to torch tensor 2. We are creating a tensor of value 2 and requires grade equals to 2. It means that we want the track of the operation involving this tensor x and construct a computational graph inside it. This enables gradient computation during backpropagation. Yeah, this will actually help to enables gradient computation during backpropagation. So what is dynamic computation graph? PyTorch uses dynamic computation graphs, meaning the graph is built at runtime during the forward pass and discarded after the backward pass. So once a backward pass is done, we discard the computation graph because it may intervene in other operations. So advantage includes flexible model structure, easier debugging, and support for conditionals and loop. Now, what is backward pass and gradient computation? So when we calling backward on a scalar tensors, trigger back propagation. Just like when you call y dot backward, gradients are computed using the chain rule and stored in dot grade at attribute of leaf tensor with requires grade equals to true. I will give example for all of them. Just I'm giving you the overview. So y dot backward means when you write y dot backward, the value, let's say y equals to x square. So y equals to x square, you have defined y equals to x square. Now you do y dot backward. When you do y dot backward, what it does, it differentiate or y like y have x square, so it will differentiate the x square and it will become 2x. Now x value is 2, so it will put that 2 at the place of x, and it get result as 4. So y equals then, and when you call x dot grade, when you call x dot grade, then it gives you value that 4. Yeah. Now, scalar loss requirement. Backpropagation requires a scalar objective. Gradients are defined as derivative of scalar loss with respect to model parameter. Yeah, I know it. By default, PyTorch accumulate gradient across multiple backward passes. Gradient must be manually cleared before the next step. So, like when we do training, it does not happen in only one step. Multiple steps happen, like multiple time backpropagation happens. So, if you will not write this function, what will happen, it will accumulate the gradient from the previous step. It starts to add it after each step. So we need to write this line so that after one step the gradient accumulation the grad value becomes 0 and it does not accumulate the previous gradient. The design allows intentional gradient accumulation for large batch training. Yeah, it happened. Actually, this design is made so for the intentionally for gradient accumulation for large batch training, where the batches has very large data. So that time it is used. Key interview takers are PyTorch tensor support automatic differentiation, requires grade equals to 2, enables gradient tracking. Computational graphs are dynamic and rebuild each forward pass. Yeah, gradient accumulate unless explicitly reset. Loss must be scalar for backpropagation. So now we will do lesson 3 next video. Thank you. And if you like this video, you can subscribe my channel.